Hello, this is Charlene. We're going to be solving quadratic equations using the quadratic formula. This is the quadratic formula, and it's important that you understand that it is the quadratic formula. There is not another quadratic formula. All these other things are quadratic equations. This is just one quadratic equation, and this is the standard form of a quadratic equation. But there is only one quadratic formula, and it is x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So we have to know what the standard form is so that we can locate our coefficients. The a is number is a coefficient to the x squared term. In ours that were given, we have a 3x squared. Then we have a bx, that's the coefficient to the x term, and in our quadratic, we have a 5 is the b value. And then in the c position is the constant, negative 7. And you do keep the signs. If it's negative, you keep the sign with it. So again, to reiterate, this is going to be our a. And I think my marker is a little bit too chunky. Let's move it down a notch or two. Okay, so that is going to be our a value. Our 5 is going to be our b value, and our c value is going to be negative 7. So we are going to plug all those numbers into our quadratic formula so that we can find solutions for the x. So it's going to be negative b, negative 5 is the b value, plus or minus square root of b squared, negative 5 squared, minus 4 times the a value, which is 3. So we got 3 times the c value, 4ac, and the c is negative 7. Like I said, you keep the negative with it. Okay, and then all of that is going to be over 2 times a, and again, the a value is the 3. Okay, then we just use order of operations to work it down. So I have negative 5 plus or minus square root negative 5 squared is going to be 25. And then we've got a minus here times a negative, negative times a negative. So those two negatives are going to cancel each other out. So it's going to be plus some number. So 4 times 3 is 12, and 12 times 7 is 84. 84. Okay, and then we also need to add those two things together. So 25 plus 84. Let me go ahead and put my 2 times 3 down here too. 2 times 3 is 6. So that is going to be equal to negative 5 plus or minus square root. And 25 plus 84, that's going to be 109. 109. And all that is going to be over the 6. Okay, so we need to see if we can find factor pairs of 109. So let's find a calculator here. Calculator. Okay, there's my calculator. So 109, I need to know what fits into 109. So I can go over here to y equals on my TI-84, and I'm going to put 109 divided by x. And then I'm going to go to my second table of points. And anywhere I see nice, neat numbers, that is going to be a nice, neat pair of factors. So I've got 1 times 109, of course. And any other nice, neat numbers? I do not see any nice, neat numbers, which means that there are no factors of 109. So that means we're just going to leave it as is. We're going to leave it as is. So that is basically all that we can do, because 5 and 6 cannot reduce. 5 6 is a reduced fraction. So that is going to give me my two solutions to solve this quadratic. Okay, our next problem is 2x quantity x minus 3 is equal to 7. It is a quadratic because once we multiply this x into the parentheses, that will be an x squared. So that qualifies it as a quadratic. And we do next actually need it to be in standard form because we need to be able to clearly see where the A value is, where the B value is, and where the C value is. So we are going to distribute the 2x, actually, not just the x, but we're going to distribute the 2x into the parentheses to both of the terms inside the parentheses. And then after we do that, we are actually going to take the 7 and subtract it from both sides and move it to one side. So we'll have everything, all the terms on one side, and it will just be equal to 0 on the other side. Okay, so let's go ahead and work it out. So 2x times x gives me 2x squared. And then 2x times the negative 3 is going to be negative 6x. And then when I subtract the 7 from both sides, that's going to be minus 7. Technically, it is equal to 0, but I don't need it in my way while I'm trying to solve and use the quadratic formula. So what are my A, B, and C numbers? Well, my A is a 2, my B is a negative 6, and my C is a negative 7. So let's go plug all those numbers into the quadratic formula. Got negative b, which is going to be negative a negative 2. I'm sorry, negative a negative 6. And that's going to be plus or minus. And then square root of b squared, so it's going to be negative 6 squared. And then that's minus 4 times the a term. The a term is the 2. So times 2. And then the c term is negative 7. So negative 7. And then all of that is going to be over 2 times the a, which happens to be a 2. So now we're just going to work it out. So negative negative 6 is going to be a positive 6 plus or minus, and I got negative 6 squared, which is going to give me 36. And then I have 4 times 2, which is 8, and 8 times 7, which is going to be 56. 56. And of course, I had a negative times a negative, which is going to cancel out and turn it into a positive. Okay, and then all of that is going to be over the 2 times the a, which is 2 times 2, which is 4. Okay, so let's keep working it out. That is going to be equal to 6 plus or minus 36 plus 56. 50, 60, 70, 80, 92. So 92, and all of that is over 4. Okay, so let's think about this radical 92. The radical 92, let's see if we can reduce that. So radical 92, that is going to be radical 2 times 46. Yeah, I think that'll work. And let's break down that 46 again. So that's going to break down into 2 times 2 times 23. Aha! I actually do have a pair of factors. The two twos is a pair of factors. So 1 2 can come out to represent the pair of twos, but 23 is a prime number. We cannot break it down anymore. So that is going to have to stay in the house. So that means my square root of 92 is ultimately going to be equal to 2 radical 23. So that's what I can replace the radical 92 over here. So let's go ahead and kind of move this up here. 6 plus or minus 2 radical 23. And that's all over 4. So what fits into 6 and 2 and 4? Well, 2 does, right? So we can divide out 2 out of all these coefficients. So that's going to be equal to 3 plus or minus 1. I'm going to let it be invisible. So I just go back to radical 23 right there and realize that I have an invisible 1 right there. And then 2 fits into the 4 2 times. So that is going to be my final answer. And of course, what you notice with these quadratic formula answers we've been coming up with is that they contain messy decimals. Well, actually radicals, but those radicals are going to turn into messy decimals. So this is considered an exact answer if we leave the radicals in it. If we were to put it into a calculator, we would get a big old decimal number with a lot of decimal places, but we would probably not be able to include all the decimal numbers, which means it would not be exact. But if we leave it in this radical format, then that means that it is an exact answer. So this gives me two solutions. I have one when I add the square root of 23, and I have another solution when I subtract the square root of 23. So those are my solutions to my original quadratic up here. Okay? Okay, our next problem says 2x squared minus 4x minus 3. And it is already in standard form, ax squared plus bx plus c. It's all in nice, neat standard form. So we already can easily see where our a value is, which is the 2, and our b value, which is -4, and our c value, which is -3. We're going to plug it into the quadratic formula. Okay, so I've got negative b, which is negative a -4, and that's plus or minus square root of -4 squared, and that's minus 4 times the a, which is 2, times the c, which is also a -3. Okay, and then all of that is going to be over 2 times a, which is 2 times 2. 2 times 2. Okay, so let's just work it out. It's going to be 4 plus or minus square root of 16, because -4 squared is 16. And then I've got a negative times a negative, which means it's going to turn into a positive, so plus. And then 4 times 2 is 8, and 8 times 3 is 24. Okay, and then all of that is over 4. And then we're going to work it down one more time. 4 plus or minus square root. 16 plus 24 is 30, is 40, I think. Yep, 20, 30, 40. And all of that is over the 4. Okay, so again, we need to consider our square root of 40. Can we break it down? So break it down into factors. 4 times 10. And we can take the square root of a 4. So that means a 2 will come out to represent the 4. But the 10, loosey-goosey, all by itself, has to stay in the house. So that means that my square root of 40 is going to be equal to 2 radical 10. Okay, so let's go ahead and rewrite that over here. That is going to be 4 plus or minus 2 radical 10. And that is all over 4. Well, what factor fits into 4 and 2 and 4? Well, 2 does. So we can divide a 2 out. We can divide a 2 out of all three of these. So that's going to end up being 2 plus or minus 1 technically, except we can let it be invisible. So I'm just going to say radical 10. And then 2 divides out of the 4. So that's 2. And that is going to be my final solution for my original quadratic. Now, I mentioned to you that these answers with the radicals are exact, but they would be a messy decimal. So let's go ahead and just quickly look at this graph on Desmos. Let's see, where's my Desmos? There it is. Okay. So I want you to see that these are x values. They are real solutions. They are on the x-axis, but they are not nice and neat. So this is the actual graph of the 2x squared minus 4x minus 3. And if you notice when I click right there, see that number right there? Oh, it's not 0. Okay, there it is. There's the one. That's exactly where y is equal to 0. It's negative 0.58114. And this one over here is going to be 2.58114. So the thing is, though, they are not nice, neat x values or nice, neat roots, but they are real. Even though they are decimals, they are on the x-axis. Okay, so let's go back and just, I just wanted you to see that visually, that these are real solutions. These are real solutions for this quadratic, two real solutions. They're just not nice and neat, which means also that we could not factor that, not easily. We couldn't. Doing our normal factoring techniques that we use, we could not factor that. So we would really need to use the quadratic formula in order to solve for these roots. We cannot factor it. It is not factorable, but that is the correct answer. So we're good to go. Okay, for this final problem for this video, it asks us to round our answers to the nearest hundredth, which means that when we get to our final answer, we are going to put it into a calculator and come up with a messy decimal answer. Okay, so we've got an A and a B and a C. And that means in my quadratic formula, it's going to be negative b, which is a negative 3, plus or minus square root of b squared, which is negative 3 squared, minus 4 times the a, which is 2, times the c, which is a negative 8. Okay, and all of that is going to be over 2 times a, which is 2 times 2. Okay, so let's just go work it down. 3, negative 3, so positive 3, and plus or minus square root of 9. Negative 3 squared is 9. And then we've got a negative times a negative again, which is going to turn it into a positive. And then I've got 4 times 2 is 8, and 8 times 8 is 64. And on the denominator, 2 times 2 is 4. And so that is going to be equal to 3 plus or minus square root of 73 all over 4. Okay, so let's pull up our calculator and we're going to put this into the calculator. So I've got, let's see, let's do fraction. Ooh, wrong one. Alpha up. Fraction and 3 plus second square root 73 in the numerator, and in the denominator I have a 4. So I get that answer like there, 2.886. So that is the first answer right there. That's using the plus. So what did I say that was? It is 2.886. So 2.886. And my other answer is going to be the same exact ratio, except that I'm going to subtract the square root of 73. So subtract and enter, and we've got negative 1.386. So the other one is negative 1.386. So these would be my two solutions, my two x-intercepts for this quadratic. So let's go to Desmos and look and see what the graph is. It's like 2x squared minus 3x minus 8. And if you notice right there, negative 1.386. Is that what we said? Negative 1.386. Yes, indeedy. And over here, I've got 2.886. So both of our answers are confirmed on our graph. These are the x-intercepts, and the solutions or the roots for our parabola that is produced by the quadratic 2x squared minus 3x minus 8. And just to reiterate, because we get these kind of answers, it means that this original quadratic could not be factored, and that would be necessitate that we use the quadratic formula to find its roots. Okay, so I hope hopefully this video has helped you go through the process and you understand maybe a little bit more about the quadratic formula and about quadratics in general. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.